Okay, and we are live. Hi, everyone. Thank you so much for joining us to another VJET session. I'm really sorry for this slight delay. We had a couple of issues with the Hangout, but I think things should be working properly right now. I'm happy to have here with us Nicholas. Hi, Nicholas. How are you doing?
Hi, Roberto. I'm fine, and you?
I'm fine. Thank you so much. So Nicholas has been with us a couple of times before, and always a pleasure to have him here again with us. So today is going to talk about securing the JVM, and I'm really excited to have a look into what's going to present us today. Before we actually dive into the session, please go to our website virtualjug.com and join us on our Slack channel. You're gonna have a link right on top. You can see it over there. Join it, and then you're going to be able to post live questions directly to me or to Nicholas, and I'll be happy to relate them to Nicholas during the session. And of course, it's also useful to have the conversation going during the session. So without any further delay, please, Nicholas, introduce yourself, and you can please start your session anytime.
Thank you very much. I will share my screen. Share it. So normally you should be able to see my screen, right?
Yes.
Okay, perfect. So thanks to be here for this talk about securing the JVM. And so as Roberto told, I'm Nicolas Frankel. I'm like a developer architect. I'm not a security expert, but I think that not a lot of developers care about security enough. So I'm a bit interested myself. Now I work for a company called Exoscale as a developer advocate, and basically we offer a cloud computing platform. We are not Google, we are not Amazon, but the good thing is basically we are a European company, so we are outside of the reach of the Cloud Act, which means that your data is safe with us. And also I have colleagues who are working nearby, and they do really great support. So now without further delay, let's talk about the reflection API in the JVM. So probably you know about the reflection API, and it's part of the GRE in the package java.lang.reflect. And if I have this code snippet, probably you know, because you already did it, what it's going to do. So I give you a few seconds to decide for yourself what will be the output of this code. Then I can run it. Let's check if you were right or not. So basically, this is what happens. I have a private field in a third-party class, and I'm able to access it through reflection because there is this reflection API. And this reflection API is something called set accessible. So that means that all the wanted visibility of things can be just removed by just like one API call, which is set accessible. And yeah, you might like it or not, but here it is. And a lot of languages or even frameworks, they use that stuff. I mean, of course, there is Groovy that does introspection, but also Hibernate and other GPR frameworks do introspection. Spring does also a lot of introspection, and they can call private methods, or they can access private fields, even though you wanted to keep them private. Now, if we go a little further, you can also do a lot of different things. For example, this one is a snippet that is a bit different from the other one. It was shown to me by my former colleague, Volker Simonis from SAP. Again, I give you a few seconds to understand what this does. And afterwards, I will run the code and show the results. So I hope you found the results. This one is not very well known. So basically, I run this snippet, and this time I change the type. So basically here, hidden is a field of type int, and basically here I should print 5. However, I replaced the value, but before I replaced the type. So basically, I accept the field, and because field is in itself is a class, and this type is an instance of this class. Field, the class as itself fields. One of those fields is called type, and basically you can change the type of an instance at runtime, which seems very, very strange because we have been told years and years that, yeah, Java is type safe, is statically typed, sorry, and basically, well, scripting language are not that great because you can change the type at runtime, but basically, Java also allows you to do that. Of course, it's not as easy. It's not designed to be done. But if you want to do it, then you can achieve it. And so basically, private is not that private, and type safety is not that type safe. And this is only technical stuff that we can make possible, but the JVM is a great platform, and it has API to do a lot of stuff. You can make network calls, you can compile code on the fly, you can execute code, you can do a lot of different things that can be dangerous, or let's say that depending on your context, shouldn't be done. Of course, you will tell me, hey, but we have these safeguards. You know, we have static analyzer that can check for patterns in the source code. And yes, the problem is that those are static analyzers. So basically, you must rely on the pattern itself. Bytecode analyzer is the same, but at least it's a bit closer to what might happen. You are into the bytecode, but again, you must know about the pattern you are searching for. You've got code reviews, and yes, code reviews, I hope everybody does them, but you need basically only 2 people to accept a pull request to merge into master. If there's 2 people, they don't care about security, or they don't have good behavior, then basically it's already inside your code. The last safeguard that I know of is security teams. And I think everybody agrees that security team is a great idea. Unfortunately, my experience with security teams is there are 2 kinds of those. The first kind is the one who are checkbox oriented, and basically they are not security team, they are security compliance team, and their goal in life is to check boxes to prove that everything was done following a specific process. They are not that useful, at least on the developer level and on the security related level. They might give some value, but basically they waste a lot of your time and they don't bring anything really new regarding security to the table, at least on the code level. The second kind of security team are the guys who really are much closer to the code and can really help you. The problem is that in general, they are not very well funded, that they are very small team and they don't have time enough to handle everything. So in the end, everything is on the shoulders of developers, or let's say a lot is on the shoulder of developers. And let me tell you about something that you might have heard about, or even, I don't know, perhaps implemented yourself, or perhaps played with as a hobby or during your study. It is called Steganography. Steganography is very interesting because you can let's say hide something, some bit of data inside a bigger piece of data. So basically you can hide a text message inside a video or a picture or anything else. So this is time for a demo where I will show you how hard it can be. So I have this nice kitten here, and this kitten is perfectly harmless. And of course, if you are doing a conference and a talk, you should always have a picture with kitten because they make people happy. And basically what I will be doing, I will hide some code inside of it, some text, but in that case, it will be code. So let's say, I will say, good evening, the junk. And I already prepared something that can hide the code. Basically, it's very easy because I'm relying on a code called Steganography that I took on the internet because I didn't want to hurt my little head. And basically, I get the main.txt and I will like hide this code into the kitten.jpg and write it as a foo.png here. So I can hide the code. And now I have this piece of code that will basically read the code, compile it, and run it at runtime. So I will extract the code or the text from the foo.png. I will like save it as a Java file. I will compile the source and I will execute it. Let's do it. And normally, if everything is fine, in the console, you should read something like, "Good evening, Vijay." And yeah, this is what can happen if you have something that is not secured. So the story might be the following, you know. I can devise a very simple process. So I will publish a new library to Maven Central. Let's say it will be a library to read images and perhaps even to write them. And then I will hide inside of it like a steganographic feature to like also extract the code, compile it, and read it at runtime. And then I will publish my library, and because it's very useful, a lot of people might use it. And at some point, then, since people will use it, then inside of my of the company, or people might use this hidden feature by just committing new images. And if you commit new image, I mean, you cannot see what has been inside. And now you can enjoy, because congrats, you have compromised the security of your whole organization. As an alternative, you might have heard, it didn't happen in the Java space, it happened in the Node.js space. There was this story about a maintainer of a very useful and used library who like didn't want to maintain it anymore. He searched for people to like be the next maintainer. One guy stepped up and said, "Hey, I will maintain the library." And then inside of the new version, he hid a feature to mine Bitcoins. So basically, if you upgraded your packages, then you got the new version, and the new version mined Bitcoins. That's not really super nice. So it can be just to steal your computing power, or it can be used for a lot of different nefarious purposes. I hope at this point you are a bit afraid, but if you are not afraid enough, then I will show you something else. You might know that inside of the JVM, there is something called the attach API. So the attach API is very easy. So I will have this attach application. It's a very simple Kotlin application with Spring Boot, and basically it offers an HTTP endpoint, and yeah, it's just like doing printing something on the std out, but pretend that it's something that really does transfer transfer money. So I run the application. It's not in debug, it's normal. I just run the application as expected. It's a Spring Boot application, so yeah. And now I can, like, let's say, pretend to transfer funds by calling the endpoints. And it gets me what I expect. So basically, I transfer the fund, and probably I miss a S here. I transfer the fund from account 1 to account 2. Bravo. Now what might happen is, because this JVM is not secured, the attach API is open. And let's suppose I am a hacker, and I can, let's try to hack the existing JVM. So you see, this is the same application. What I'm doing, I will be attaching, this is called attach API, because I will be able to attach myself to this application and change the bytecode when it runs. The only thing that I need is the PID. Oh yes, it's not that easy, but still a bit. And it's done. And now when I get back to my application and I try to transfer from the same account to the same account, the same sum, congrats, the JVM has been hacked. The code has been completely changed at runtime without any issue. And the code to get that is very, very easy. Basically, it's just like 5 lines of code. Of course, you just need to get the source code to change it according to your needs, and then you can put it back. But the code to do it is very, very easy to produce it, actually. And worse, because now if we get back to the application and then we restart it, then what happens is that it's back to the initial state. So basically, I left no trace. That's one of the worst hack ever, because basically it's very hard to follow what happened. So I hope now at this point you're really, really afraid that you want a secure JVM. And perhaps in that case, you might remember the old people like me. They remember the applets. And the applet people, the people who designed the applets, they were also concerned about the fact that basically an applet is a way to download code on your computer and execute it. And this code comes from the internet, and so it can be compromised. It's not that good. So the applets, they were forbidden to do dangerous stuff. And in order to forbid them, they were meant to run in a sandbox. And so basically, the JVM already has this like concept of sandbox. You've got 2 modes. The God mode, which allows you to do everything, as I showed you before, and the sandbox mode, which like filters what is allowed or not through a so-called security manager. And activating the security manager is very easy, actually, because you just need to run your program, your Java program. You need to launch a JVM with this java.security.manager system property, and presto, you've got the security manager installed. An alternative, which I don't advise you to use, is via the API, because basically API, well, before you call the system.setSecurityManager, before that time, you can have an insecure JVM. So it can be compromised already. So the thing to remember is there's a system property. And so you've got permissions. The permissions are quite granular. We will see it a bit later. And they can be configured in a Java policy file. This Java policy file is different before Java 9 and after Java 9. So before Java 9, so on Java 8, it's in the GRE lib security. And with Java 9 on, it's on conf security. It's referenced through another file called Java security. So Java security references the Java policy, and in both cases. However, probably not everybody does microservice. So you can have a JVM that runs multiple applications. In that case, having a single policy file is not advised. And every application that uses the same JVM should have a dedicated policy file. There are 2 ways to set the policy file. The first is to set the policy file. So basically, it will replace every permission from the default policy file. And you need 2 equals. Or you can add additional policy, and then it will use the default one plus the one that are defined in my.policy. Of course, I would always advise you to like replace everything so you know exactly what it is, because again, if the default policy file has been compromised, you don't know, and you can add any permission you want. The fishnet will already be too large. So probably you know in security about the principle of least privilege, and the principle of least privilege is the reason why when you have an issue, I don't know, running a PHP application and you don't have the permission, you don't chmod 777, because you basically allow everybody to do everything. Of course, it solves your issue, but on the opposite side, then you've got a lot of other issues now. So basically what we want to do is to have the minimum set of permissions to run our application. And the default one are very few indeed. The default one, at least on Java 9, is to listen on ports and to read a few system properties, not all of them, but just a few. You might check the policy file on your JVM distribution. It will be very interesting. And the good thing about permissions is they are enforced in the JDK itself. So though it might be possible to compromise that, it will be very, very hard. And as you can see here, if you call the setAccessible method that we called earlier, it will get the security manager, and if it's not null, meaning if it has been set, then it will check the permissions. And this is enforced in the JDK itself. So it's a very low-level stuff, and it gives a high confidence in the security. I will just show you how it can be done. I will close this application. I will go on the JVM security stuff. And now what I can do, I want to run the oops.java, so how to access your code. I will just add the .d java.security.manager. So this is a VM option. And now if I run the same code, normally it should be very unhappy. Because this is having like access to a private field. It's something dangerous. It's something that compromises security. It shouldn't be allowed in most cases. So now it tells me, hey, your access has been denied. And it references something called the reflect permission. And we can see that there are a lot of permissions. So I won't go through all of them. The table is just for reference purpose. There is this interesting all permissions that gives you every permission ever. I will get back to it later because it shouldn't, of course, it shouldn't be used in production, but it's very useful in very specific use case. You've got a property permission, so you can read system property or write system property, file permission, reflect permission, runtime permission. Okay, a lot of permission. Interestingly enough, there is also this AWT permission, meaning that your JVM in production can read the content of the clipboard. So if you happen to copy-paste your password and you didn't secure the JVM, it can access the content of the clipboard and perhaps transmit it to, I don't know who. And this is the structure of a policy file. This is very simplified. I will only talk about permissions here because also you can sign your jar, you can do different stuff to secure your JVM, but here is very, very simple. Basically, I'm just telling, hey, when I run this jar, then I have this foo permission with this foo parameter, and when I run this jar, and I have this bar permission with parameters bar and bars. So very, very simple stuff. So there is a question, if we use security policy, will it not break frameworks like Spring, which depend on introspection? The answer is, by default, yes. But again, we must give the permissions that are just enough to achieve our goal. So if you use Spring and if you use introspection, then this is okay to allow the JVM to introspect your code. On the opposite side, if you don't use Spring, why should you allow any library that you use to introspect your code. That's not a good idea. So it's just a simple example of the principle of least privilege. If you need it, use it. If you don't need it, then don't use it. And what we'll be doing afterwards is we will try to secure a Spring Boot application. That's exactly the time for that. So I have the Spring Pet Clinic. And if you don't know about the Spring Pet Clinic, I will just launch it once to show you how it works. It's very, very simple. It's just a showcase application for the Spring framework. It's not the important stuff here is not that it's a Spring Boot application. It's just that this is very, very useful. So for example, here it has been done. And now I can check the Spring Boot application. So I have the Spring Pet Clinic here. I didn't build it before, so that's why I don't have the right CSS, but don't worry, it's fine. I can have the home, I can find the owners, I can find the owner, and it gives me a table. I can find veterinarians, and also I can check that some error happens or not. So that's very good way. I throw an exception, and I check that my frameworks, my lib, my configuration handle it nicely. Again, I didn't compile the CSS, but I don't care so much now. Okay, so this is the Spring application. And what we are trying to do now is we will design a very simple JVM policy file. So I will start from this file. So this is the jar that I'm using. It's a U-boot jar. It has everything. And now I will try to run it with only a single permission. And immediately we've got an exception. Immediately we've got the exception that, yeah, we need a property permission because the Spring Frameworks wants to read the java.protocol.endler.pkgs property. Okay, so let's do it. So I add the permission that it requires because I want to be the least privileged, to apply the least privilege principle. So I will just add permission one by one until I can run my application. And now it's the same permission, it's the same property, but now it wants to write it. So here I can show you two different ways to do it. You can do that, or alternatively you can do that. So now it's a new permission. No, it's not a new one. We already had it. And now it's a set factor that it asks for. And then by doing this baby step stuff, basically I can have the least privilege implemented. Now it's a new permission, net permission. Now my question to you is how long do you want me to do that? Because it's going to take a long time, I can tell you. So do you have, let's say, a few hours in front of you?
Yeah.
Yeah, okay, let's do it then. I'm not sure everybody is able to do that, unfortunately. So this is just for fun. Yeah, and it's going to take a long time. And the final policy is like 200. And I already took some shortcuts, which is not good. So I would stop there, and I wish, and I believe that's the reason why in my 15 years of consulting, I've never seen a properly secured JVM, because the creation of the policy file takes a long time, and every time you change your application, you need to redo your policy file. Perhaps you need to add more permission, but most probably you need to remove permissions as well. So you cannot like just add permission because you will contradict the principle of least privilege. So you need to restart from scratch. Fun part, if you change your library version, perhaps they require also permissions. So not only if your application changes, but if you change the version of your dependency, then you need to do that from scratch. So if you need to waste this time, to spend this time every time, it's going to be a bit boring, and probably your project manager and your customer won't be super happy about it, because for them it's time lost. Of course, for you it's not time lost, but for them it's time lost. So I devised a way that you can do it for real, for non-trivial applications, for non-hello world application. And the concept is quite interesting. Basically, I told you about the old permission. So I have this permission that grants everything. What I will do is I will use it, and with it, I will just also log every time I need to access a permission. So every time it asks me for a permission, it will log it. And in that case, what I can do is I run the application. And as you can see, there are a lot. Of course, there are a lot of duplicate lines also, but most of the cases, they are not that duplicated. It's just starting. I will just like copy paste it into a new file. And I will just want to show you something. Is now that I have started the application, it's not finished. So here I will like reset it, and now I do something with the application. And as you can see, starting the application doesn't trigger every permission access request. You need to run the application and to go to every button, to every link, to do everything that your application allows you to, if you want to be really exhaustive about the permissions. But I hope that you already do it during your automated integration test. So that shouldn't be an issue. And now what I can do is basically, I will do it by hand, but probably you can do it with something more interesting. I will like, how is it again? I will find all lines that start with that. So I will find all, and I can copy that. Because now I have the logs that are like permission related, and I have the logs that are like normally Spring Boot related. So I can now do that. And I can start to remove the stuff here. For example, so I won't do it to all the 8,000 lines, but my point is basically I need to process a line like this to make it a line like this. It's as well super boring. It's not very interesting, so I won't do it. But I advise you to do it in an automatic way, or to use like any good text editor to do it, because otherwise it's a lot of trouble. Something also that you should do very easily is what we can do. For example, I need at least to do that, because here there are a lot of duplicated lines. So here I will do like this. And I will do like this. Just to show you that there are a lot of, I removed too many. I removed too much. Here, and you remove duplicated lines. I don't remember where is it. Here, process duplicate lines here, and you leaving one. So you can process and it removes already some crap. Not every crap, but a lot. So don't be afraid because there are like a lot of lines here. You can remove a lot by removing the duplicate. Depends on your text editor. Anyway, and afterwards, finally, then you are able to craft your final policy file, which looks a bit better, like this. It's not that big. I told you I took some shortcuts, and I will explain to you, but I just want to do the demo first. So now, the configuration is very simple. I'm just using like the final policy, and that's all. So it starts nicely, as you can see. And I'm very, very close to a minimum, a least privilege file. Very close, but not completely. And I can navigate. And I have permission issues. So there are some shortcuts. I wanted to tell you about the shortcuts because I believe that that's really an issue. One of the first shortcut I took is about the property permission. Yes, this one. Here, I did something very, very bad. Basically, I used the Joker character, which basically makes every property readable and writable. And basically, that means that those are also not necessary. Why did I do that? Well, one of the reasons I did that is because in the Jcache implementation inside of the JVM, instead of checking for some properties, basically they are iterating through every property to check for the value they want. That defeats the purpose. So at least what I should have done, I mean, that cannot be helped, but at least what I should have done is I can read every property, but I can only write a few. That's the first shortcut. Also, there is another issue with the Joker character. You can find it here. Yes. Also, here I am able to access any environment variable. That depends a lot on your framework, but Spring Boot is very greedy considering that. And about the socket permissions here, I have an issue because I don't know which port it will bind to. I didn't check the docs, but you might be able to set the port once and for all. And in that case, you can remove the Joker because you know which port will be done. But otherwise, if there is some random, you have no clue, and then you need to use it.
Hey, Nicholas. So I'm actually making also a question coming here from our Slack.
Sure.
So you mentioned that, for instance, the Jcache, I believe, right?
Yes.
Implementation. You're saying that they have some code there that basically is reading everything, so that's why it generate that kind of permission, right, with the star and the read and the write. So basically that means that some pieces of our code may actually require a lot of permissions that we actually don't really need.
Yeah, exactly.
And that generate bugs, right?
That doesn't generate bugs per se, but from a security perspective, that widen the attack surface for no really good reason.
Yeah, so, not like a feature bug, but I'm saying a bug that may be exploited for a security purpose, right?
Yes. So if the Gcache implementation team, then you can tell them that they should really change that.
So and that comes with a continuation question coming from Slack, which is there a way that you can set up a security policy at the granular level, basically saying only certain classes can have certain permissions, or when you set up permissions there for every class in the JVM?
And that I think that's one of the limitations. Basically, here I'm bound by the default security manager, which read this file permission. So you can only set it at the jar level. I think you can use it. I'm not sure whether you can use it at the lib level. I'm far from sure. What you can do, if that's of interest to you, you can devise your own security manager, and then you can do whatever you want. However, I really wouldn't recommend it because it's a huge investment, and I'm not sure the benefits is on par with it. And again, whether you do it or not, then I'm not sure. For example, you would need to check whether the read permission is required by JCache or whatever, and it will be a lot of boilerplate code that you need to do. So I wouldn't advise it. If you really want to do it, you can do it, yes. But then it's just to create your own security manager, which, again, I've never seen, I've never done, and I cannot advise you to do it.
Okay.
Here you can see also that I have said some stuff that shouldn't be static. But for example, if I remember well, I have this. So here I have these users Nico, because my Linux user is Nico, and probably that's the good stuff is here. You can replace it with user home. The good thing with this permission file is that policy file. Sorry, you can have some degrees of like variable usage. So that should already be an improvement, because then it makes your file more portable, because probably you don't want to craft a policy file per environment. Well, probably at all. Then there is this one, for example, and this is the host name. And again, you don't want to have this like hard configured. So either you find the right variable to change it, or you can have a template engine that replaces it for every environment. Also, because like in that case, Spring uses a lot of like on-the-fly instrumentation and creates class on the fly. You need to handle that, and you need to let. So there is. It's not star. It's that one. Let me check it where I can find it. Yes, here, for example. This is the Tomcat Spring Boot integration. So basically, Spring Boot will create a lot of stuff under the TMP folder. And here I'm telling, you can take whatever you want. I don't care, because basically I have no clue at configure time what folder you will be using. So I cannot be very granular. So I need to let you do your stuff. So it's very framework dependent, of course. And I think that's already a lot of shortcuts that I took. But even with those shortcuts, for example, I've got these 250 lines of permissions. I've got a question. How does it work with GPMS? Doesn't it already restrict a lot of those unwanted access? That's a good question. So I didn't, to be very honest, I didn't dig on the question. But the problem is who is using GPMS today? You might have read my latest blog post about who is like how many libs and how many applications are already using GPMS. I believe not a lot. I believe not at all, actually, in production. At least none that I know of, sorry. And because the problem with the module system is, in order for your application to be modularized, you need to be dependent on modules. And since a lot of libraries are not modularized yet, that prevent anything to work. For example, the Spring Framework is not modularized because a lot of the dependencies are not modularized. And it's a chicken and egg problem, because if there is no incentive for library maintainers to modularize their code, then they won't do it, then they won't be used, and it's a vicious circle. So it might be the case, but to be honest, I didn't check. And then this is nearing the of the presentation. My point now is you've got two choices actually. You've got the red pill or the blue pill. You can pretend that whatever happened into this presentation never happened, and you can forget about securing the JVM because, again, in 15 years I've never seen it once secured, at least that I know of. And everything happened fine, and whatever, and everything is fine. We all live in the best of the world. Or you can think that perhaps because you listen to this talk, but perhaps another bad guy also listened for this talk, and he might try to do the same trick that I showed you, like have a very good library that is very useful, and then introduce hidden steganographic features or attach API feature or stuff like that. And this is a risk that that needs to be managed. I cannot answer whether you should use a security manager or not. What I can advise you, however, is it's a risk not to use one. And as a developer, you should, or an architect, or I mean an IT person, you should be able to manage the risk through a risk management plan. So first, you should assess the likelihood of the risk. So how likely it is to for this to happen. And of course, if you are using, as the question was asked, module system, or if you are running your stuff into a Docker container, it decreases the likelihood. It doesn't like completely remove it, but it decreases the likelihood. And the second step is to assess the severity. And then again, it's context dependent. If you are, I don't know, working into the banking industry, or if you are creating software for planes or for surgery engines and stuff like that, the severity of the flow, if it happens, will be very high. And the third is, how much does it cost to mitigate the risk? And this cannot be not for you. I cannot be done for you, sorry. I can only tell you and raise awareness about what might happen, but this risk assessment plan is only context dependent, and you can only do it into your own context. So thanks for your attention. You can read my blog. You can follow me on Twitter. And here I've created two links. The one is for the Spring Pet Clinic on the security. I've created a dedicated branch with those polyphy files that might be interesting to you. And also I've created like a small series of articles that goes deeper into the security manager stuff, because actually you can use certificates to be sure that only the right role, the right person is running the jar, and blah, 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 and blah, blah, blah. So if you're interested about this thing, then you can dig further. And now I might read the Slack for more questions.
Yeah, so I have another one here coming from the YouTube channel directly. So you mentioned that these demos are or actually the links that you sent. One is for the pet clinic, and the other one is from some of your articles. You have a link for the demos that you just showed for the IntelliJ code?
You only have the code for the pet clinic, because the hoops stuff, I mean, I believe the hoop stuff is very easy. I mean, and probably you already did it. And the attach API, I can write it down into the Slack, because yes, it's available online. I forgot to write it down. But the hoops and hoops, again, I mean, is very easy. Just remember that a field is a class like any other, and then you can access its own fields and change it. The steganography, the code in itself is not very interesting. The process, I believe, is very interesting.
Yeah, I think those are kind of easy, but probably the one with the kitten, it's probably more interesting for people to see actually and playing with it.
I will post the attach API hack if you believe, because this is very hard to detect, and it can cause a lot of trouble. Especially, I know some people that use it to have zero downtime deployments. And at least if you are aware of that, if you are using it for your own purpose, it's fine. But if you are just open, like running an unsecured JVM, then it can happen to you, and you will be very sad if it happens. So yes, I will either I will change the slide. I will add it to the slide, and then I will publish the slide. I will share the slide.
Wonderful. Then we have here another question from Jan. I hope that's how you spell it. The bulk granting of permissions based on observations, which ones get used may have some limitations in the context of the Steganography hack in the opener. If the malware library uses the permission required for its bad stuff in diagnostic run, the permissions may be granted, maybe carry on doing whatever bad stuff it does.
That's a very, very good observation. It's true, yes. It's true. I hope, though, that I told you about code reviews and static analyzer and security teams. But now, perhaps, because now it's much easier to check. Because now what you just need to do, is to get to the final policy. And then you can read not the whole code base, but you just need to read 250 lines. And if something here seems fishy for whatever reason, then you can ask, but why that this permission is there? And then you can remove the permission, rerun your application, and check where it comes from. So yes, it's true. If you're doing step by step, might be bad, but at least this is much easier to audit than the whole code base.
And maybe one thing that you also can do is, since you're able to do the policy on jar, I mean, of course, there's always going to be some kind of a risk, but at least for the jars that you actually trust, ones that are signed for your team or really popular things that you really should trust, then maybe you can just give permissions for all of that, and then you can just focus on the ones that you don't really know about.
If you are really working in a very sensitive environment, because the problem is that you might trick people. Basically, you might audit the source code of your libraries. Let's say you might audit the Spring Framework or Log4j or Slave4j and see that everything is fine and be happy about it. But basically, the problem is you have no way to trace the source code to the jar. So you don't know if the source code is actually the only source for the jar. So if you really, really want to make sure of everything, what you should do, what you actually must do, is that you need to build every dependency yourself on your own continuous integration platform. And this way, you're making sure that the source code is the jar and nothing bad has been introduced. And it's a lot of work.
It is.
But again, it's in certain contexts, it might warrant that. It might warrant that. Because if you are, I don't know, again, if you are in the banking industry and yeah, I showed you how easy it is to hijack a JVM, a lot of stuff, you can do a lot of bad stuff. So if the costs overweights the benefits, yes, of course, you shouldn't do it. But if the risks outweigh the costs, I'm not sure you should just discard that option.
Yeah, so we have another question on the YouTube channel from Honkatonka, I believe, if I spell that correctly. So we have permissions files. These are tedious and likely to break. Are there any other approaches on securing the JVM?
Sorry, about Alkinian, I didn't understand the question.
So I was saying that, so you were showing stuff about permission files, right? Those are tedious and they are likely to break.
Yes.
So are there any other approaches to secure the JVM?
Baked into the JVM, no, that's the problem. Actually, the traditional security that I've seen is used, is to close ports, put firewalls, like silo network zones and stuff like that. But that's only one part of the issue. You are basically securing the lower layers, but you forget about securing the higher layers. This is the way to go if you are a JVM user, if you are a Java developer. This is the way to go. And yes, it's tedious, but I hope that with my process, it gets much easier. And at least it's acceptable to do it once in a while. And it reduces the risk a lot.
Wonderful. Well, I think we're pretty much out of time. So I would like to thank Nicholas to be here with us today to give us this awesome presentation. So maybe, Nicholas, you might want to stop sharing so we can see your pretty face.
Oh, I'm checking how I can stop sharing.
Yeah, just click the green button on the side.
The green button on the side. Yes.
Okay.
There again.
Yeah, it was a wonderful presentation. I learned some of a lot of things that I haven't have any idea. So thank you so much for that, and I'm pretty sure a lot of our audience also learned about it. So thank you so much for bringing us this topic to the VJUG. I hope that you have fun. We certainly have, and we hope that we can see you again in another VJUG session in the future.
I will be very happy to, Roberto. You are always very kind. It's always a nice organization. On that touch, I want to finish. That's the first idea for this talk. It was at the conference, and I approached the organizer and told him, hey, next year I might submit a talk about securing the JVM and about the security manager. He turned to me and he told me, but everybody knows that. And I've done that talk a lot of times. And that the funny part is, I think it's very old stuff. I mean, I don't know. Perhaps it might be like Java 1.1 or perhaps 1.2. But not a lot of people use it, and that's really bad stuff because I think that the developers need to be more concerned about the security. And if you are a Java developer, it should be part of your, at least of your area of knowledge, that you know that it exists.
Yeah, I mean, I think we got that discussion some time ago. And that's more a general comment. Like all these boring or old topics that people sometimes say, oh, people already know about that because we discussed like 10 years ago or 15 years ago, but they don't remember about the new developers coming in that they never heard about this in the last couple of years. So I think that's refreshing, even if it's an old topic. There's new developers coming in and they have to learn about these things. So I think that's always useful to have these kind of talks.
Thank you very much. So now it's up to you guys, red pill or blue pill. Choice is yours.
Yeah. So let's have our audience pick which one that they want. Yeah, guys, so thank you so much for staying here with us, and really sorry for the slight delay in the beginning. So stay tuned. We're going to have a new session by the end of the month, so please go to our website and sign up for that one. And without further delay, so thank you again, and see you next time. Bye-bye.
Bye, guys. Have a good evening. Bye.